Hello everyone, in this video we're going to be solving a logarithmic exponential system. So we have x to the power log y is equal to 1000 and x times y is equal to 1 million. In this case I'm using log with base 2, base 10. So log y means log y with base 10. Okay, so it's the decimal system that we're using here. And it makes sense because we have powers of 10 on the right hand side, which is kind of nice. So in order to solve this system, I'm going to be using logs, obviously. Anytime you have an exponential expression, especially if the exponential expression is a log, that would make so much sense to use logs because it's just going to bring the exponent down. So let's start by logging the first equation on both sides. Now, we're not writing base 10 here, but always know that when it's not written, it's base 10. Okay, I know some people call it the natural log, but we're not talking about the natural log here, which is ln, right? It's backwards, by the way, logarithm natural, so because it's French. Anyways, that's another story. But this operation basically brings the power down. So I can just move this guy over here to the front, as you know, using properties of logs. That gives us log y times log x equals log 1000. Log 1000 is, because 1000 is 10 to the third power, it's just equal to 3. So you're basically asking the question, how many zeros do you have? The answer is 3. Okay? Or 10 to the power what number equals 1000? The answer is 3 again. So now we got something nicer, I think. Instead of an exponent, we got a product, which is cool. Now, how does that help me solve the problem? Especially looking at the second equation, should I be doing the same thing or should I do something else? Obviously, at this point, you can just go ahead and replace y with something or x with something. So you can use substitution. That is fine. But I'm not going to do that. I'm going to log both sides because it's more fun, right? Don't you think? Okay, let's log both sides in the second equation. That gives us log xy equals log 1 million. And 1 million is a very large number, right? Depending on your unit, of course. If you have $1 million, that's kind of cool. Anyways, this is log 1 million, which is 10 to the 6th power. And as you know, log xy, we have the product to sum. Is that what it's called? Or just expanding it? Whatever you want to call this, log xy can be written as log x plus log y. And then log 1 million is 6 because it has 1 million has 6 zeros. Great. Now, we didn't check the domain of this equation, but if you look at it very carefully, you're going to notice that y needs to be positive. Since their product is positive, x is also going to be positive. So we're only looking for positive solutions, and don't worry, we're going to be looking at positive solutions only. Okay, now what did I get? By logging both sides, I got this, and I got this. Is that good? Absolutely. Look at that. We have two variables, and that is going to make a quadratic equation. But first, we have to use our awesomest method, which is called substitution. How to use substitution? Let's call log x. Let's set it equal to a. And let's say log y is equal to b. If you don't like a and b, you can use c and d or whatever other variables you like. Doesn't really matter. So I can write my system as ab equals 3 and a plus b is equal to 6. Now you can think of it in several different ways. You can isolate b's, plug it in, so on and so forth, and go from there. Okay, now do we have the symmetry here, like are x and y interchangeable? Probably not. We can check that later on as well. Okay, let's go ahead and find the values from here. What am I going to do? Well, I can just, okay, let's isolate b. 6 minus a, and then plug into the first one. So I get a times 6 minus a is equal to 3. From here, I get 6a minus a squared is equal to 3. And a squared minus 6a plus 3 is equal to 0. Great. So now I got a quadratic equation, and I should be able to solve it. Let's use a method that we haven't used before. So let's just go ahead and add 9 to both sides, because we always use the quadratic formula. Add 9 to both sides, you're going to be getting this. And then from here, you can just write this as a minus 3 quantity squared is equal to 6. And this gives you plus minus root 6. And by adding 3 to both sides, you get the solutions 3 plus minus root 6. Okay, now we gotta check obviously both of these solutions and also make sure that this is a valid expression. Now what is a and what is b? Well, b is just gonna be 6 minus a. So if a is equal to 3 plus root 6, then b is supposed to be 6 minus that, which is going to be 3 minus root 6, right? Because in other words, their sum is 6. And if a is 3 minus root 6, then b is supposed to be 3 plus root 6. So they kind of switch around. But what are the x values? We're looking for x and y, right? Well, we said that log x is a and log y is b. So let's go ahead and get back to it. Log x is a. So since a is 3 plus root 6, for example, from here we can get the first value, or log x will be 3 minus root 6. Okay, now, if you do 10 to the power both sides, or use the definition of logarithms, from here you're going to get x equals 10 to the power 3 plus root 6, and you're going to get x equals 10 to the power 3 minus root 6. Okay, great. Well, we know that x and y both have to be positive, and since these are powers of 10, obviously they are going to be positive, right? Okay, great. And we know that 3 minus root 6 is also positive, but that doesn't really matter much. So now, anyways, these are the solutions for x. And then let's take a look at the y values. But here's a $1 million question. Well, maybe we'll find the b values first. Well, we did, sort of. So in other words, if x is equal to 10 to the power 3 plus root 6, from here y is going to be 10 to the power 3 minus root 6. And if x is equal to 10 minus 3 root 6, then y is going to be 10 to the power 3 plus root 6. But here's the thing. If you look at the original problem, first of all, multiply x and y. In both cases, you're going to be getting the same product. So xy is going to be 10 to the power 6, which will be verified. But what about the second equation? I mean the first one, right? Is that the first one? I think so. Okay, the first equation gave us x to the power log y, right? So let's go ahead and check that one. If you have x to the power log y is equal to 1000, is that going to be satisfied as well? Let's go ahead and check it out. So in the first case scenario, I have 10 to the power 3 plus root 6, and I'm raising it to the power log y. And remember, log y is just going to be the power of y, which is 3 minus root 6. And when you do the operation here, you're going to get 10 to the power 9 minus 9 minus 6, which is 10 to the power 3, and that's going to be 1000 from difference of 2 squares. So that works. What about when you switch them around? Interestingly, it's also going to work because the commutative property is going to allow you to use this property. So even though the equation doesn't look like it's symmetrical, both of the solutions are going to work, as you can see here. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.